So now that we know how to find our t-star, or our critical value, for a confidence interval with means, now we're going to put it all together and actually create the interval. So these steps should look very similar based on what we did last week. We're going to check our assumptions and conditions, which of course we'll review in a moment, and then we're going to tell what model we're using. In this case, that would be a student's t model, and in this case, a sample t interval. Then we're going to perform our calculations. Here's basically a list of everything. Remember last week I like to just sort of stick it all together, but of course when you're working in my stat lab, sometimes they're going to ask you just for the critical value, or just for y bar, or just for s, etc. So it's important to understand what each part means. Y bar and s, these are our sample statistics. We're going to take the values that we're given and we're going to find our mean and standard deviation. Now quite often, unlike last week, they're just going to give you a list of data. And so if they do that, you're either going to plug them all into your calculator and do 1-bar stats, or you're going to use StatCrunch to find these two values for you. The standard error we talked about was the standard deviation of our sample divided by the square root of n. The margin of error is just like last week we had z star times the standard error. This week it's t star times the standard error. Or of course, if you want to replace standard error with s over radical n, that might make a little bit more sense. And then if you're putting it all together, this is what we're looking at. The y bar, which is from our sample, plus or minus t star of n minus 1 times the standard error. And then of course we state our conclusion just like last week. So let's take a look first at the assumptions and conditions. So as a reminder, we're doing independence as we did last week, randomization, and 10%, all like we did last week. The nearly normal condition is instead of the success-fail condition. And so nearly normal means that you're either going to make a histogram or you're going to make a normal probability plot. Because histograms can be a little bit tricky depending on the way that your calculator or StatCrunch bins them for you, I like to do this normal probability plot. So as we work through our examples, you'll see that that's the method that I'm choosing, but you are welcome to make a histogram yourself. Keep in mind, as our sample gets larger and larger and larger, it's safe even if the data are skewed. So if I'm looking at small samples, which quite often we're using in a student's t model, we really need to make sure that it meets that nearly normal condition. So for our first example, I have 10 randomly selected high school basketball teams and their scores. So for their scores for a certain week. So these are all of their scores. I have them in least to greatest order, but it doesn't matter. And I'm trying to find a 90% confidence interval for the mean scores of all high school basketball teams. So again, we're looking at 10 teams. I need to check my conditions before I'm able to say, yes, I can continue, or no, I can't. So independence, obviously the points scored by teams are independent, assuming they're not playing each other, but since we've chosen them randomly. Randomization, the teams were sampled randomly because it told us. 10%, 10 is less than 10% of all high school basketball teams. Nearly normal condition, notice what I've done is I've taken all of these values and I've plugged them into my L1, and then I went to second y equals, which is that stat plot, and notice I'm choosing this last one. That's our normal probability plot. Now, if you don't like the normal probability plot and you want to make a histogram, of course you would choose this one instead. I like the plot, and what I'm looking for here is I really just want a nice line just like that, a nice straight line, and that's what I have, and so it's okay. So the normal probability plot appears nearly normal. When you're checking this in a case study, you don't have to show me that. You should check it and then tell me yes or no. Just like last week, I'm going to then say because the conditions are satisfied or met, I can use the model, which is the student's t model, and then the test, which is a 1 sample t interval. Really make sure you learn the names, because next week I'm going to throw 3 or 4 more at you and make sure that you understand which ones we use when. Now I'm going to perform my calculations, and again I'm going to utilize my calculator to find this value for me, and this value for me, and this value for me. So let's talk about it over here on the right, and then I'll show you how to do all of these things in StatCrunch as well. If I have all of my data in my L1, as I did on the previous screen, I can find my 1-var stats, which will give me the mean, y bar, and the standard deviation And so I'm just going to go to one var stats and then L1 and then calculate, and that's it. And notice here I'm using 57.8 for my mean. It says X bar, we call it Y bar, it doesn't matter, it's the same thing. And of course S sub X, that's the standard deviation that I'm using. I rounded it to 3 places. 3 or 4 is a good way to go. Don't round it down to 2 or you'll regret it. Now in terms of this, which is of course my T star for 9, notice T star of 9 because there are 10 scores and n minus 1 would be 9. I'm going to use my second vars and T inverse T, which is what we did in our last video to find our critical value, and I found 1.833, and notice that's what I'm using here. Just like last week, your best bet is to just do all of these calculations in one swoop, which I did to get 3.487, and then I'm subtracting it first and then adding it second to get my 2 values. Now, just like last week, we're going to write our conclusion in context. I'm 90% confident that the mean score of all high school basketball games is between 54.31 and 61.29 points. So notice here I'm saying that it's an average, and I'm extrapolating to all high school basketball teams, and this is the range that I feel that the actual mean score is in. So I'm not saying that they're going to score between those two. I'm saying if we actually took every single high school basketball score and we found the average of all of them, that would then give us the mean rather than Y bar. And I'm saying that mean, I'm 90% confident that mean is between those 2 scores. Now, if you're using StatCrunch instead of your calculator to make your normal probability plot, when we checked that nearly normal condition, we go to graph, QQ plot, and then select the column that your data is in, and then compute. And notice it looks good. And if I'm going to do my 1 var stats, I'm going to do stat, summary statistics, choose the column that it's in, and then compute. And of course that gives me my 57.8 and my 60.15. So here's a question for you to try on your own. I would like you to press pause, try this question in its entirety. Don't be afraid to utilize either StatCrunch or your calculator to find the 1 var stats or the summary statistics for you, and of course your critical value. Once you've done so, please press play to check your work. So our question here has a goal of developing a battery that has over 5 hours of continuous use, or 300 minutes. So again, notice we're going to measure everything in minutes because that's what these values are in. So 300 minutes. In a test of 12 batteries, so that's N, that's the number of observations, we measured the lifespans given here. And we want to know if the mean battery lifespan exceeds the 300-minute goal set by the manufacturer. Now, obviously, this is set up to do a hypothesis test, which we don't know how to do yet. So now we're just going to check it using the interval. So we're going to test the claim. So we're going to construct our interval first by checking our conditions. So our conditions are randomization. It doesn't specifically say that it's random, but we are going to assume that they are. 10%, 12 is less than 10% of all batteries produced by this company. Independence, battery life of each battery is independent, and nearly normal, I've made a probability plot and it looks like a nice diagonal line. And then because the conditions are satisfied, I can use the student's T model to find a 1 sample T interval. Now I'm going to utilize some technology to find that my mean was 306.25, my standard deviation was 29.31, and my critical value, or T star, for 11 was 2.201. Then of course I'm just going to calculate that value to get 18.623, and then here is my interval. Then of course I'm just going to finish by writing my conclusion, which is that I'm 95% confident that the true mean lifespan of batteries falls between essentially those 2 values, which is 287.63 minutes and 324.87 minutes. Now, because I'm sort of testing a claim here, it says we'll use these 12 batteries to test the claim. Notice that I'm testing the claim of if it's exceeding 300. Well, looking at my values, 300 falls in my interval. So if 300 is in my interval, do I think that it's going to exceed those values? No. If I were going to reject or fail to reject, I would fail to reject the null.